Hello, I'm John Greiner, and I'm going to be doing your July 2020 safety meeting. We will be covering personal protective equipment, electrical safety, as well as GFCIs. Now, there's a lot of information in here. However, we're going to move through it pretty quick as a lot of the information is relatively standard for the different jobs that we do out here in the oil field. So the objectives of this training on the PPE side are to understand the PPE assessment process, understand why different types of PPE are selected, and know how to properly wear and care for PPE. So I'm just going to go ahead and skip through that one there. Hazard assessment. Like I said in the objective here, our goal is to essentially know when we need to wear PPE. And hazard assessments can be done formally with documentation or just a quick review and even put into the JSA. So obviously we want to evaluate the different jobs that we do or that we plan to do, determine if anything is a hazard, and obviously first thing we want to do is eliminate the hazard before we put on PPE. And then lastly, if it cannot be avoided and we have to work around the hazard, then determine the type of a PPE that's necessary. So we're going to kind of go down the list here of the body, just kind of cover the different areas that need to be protected against. So face and eyes, obviously our big issue are flying particles. We've all seen videos and pictures of people with pieces of metal or brushes in their eye, and it is not pretty. Sometimes they rust and can cause some pretty serious permanent damage. Molten metal, obviously also a big issue. Hazardous liquids, acid or caustic liquids, a lot of different types of liquids to harm your eyes. Gases or vapors as well, especially things like H2S can cause damage to your eyes just because of the acidic nature of the vapor itself. And if it makes contact with the mucous membranes in your eye, it can cause damage. Lastly, light radiation. So whether it's lasers or welding, if anyone's ever been around a welder and not had a welding shield or glasses on, you've definitely experienced essentially flash burn. You get the little sandy feeling in your eyes. It is not comfortable by any means. Also, respiratory protection, so kind of moving down to the lungs. Airborne dust and particles, huge issues in the last few years, especially surrounding fracking from the silica dust getting in people's lungs and causing long-term problems. Vapors or fumes, just like the eyes, the nature of those things can block aspiration or air from being transferred from the lungs into the blood and cause a lot of other issues. Lack of adequate oxygen. During that process, you want to make sure you find the sources and eliminate them, review what you're doing and monitor the exposure. Also having good plans like standing upwind, when you're doing certain work, not being downwind of anything that's creating dust or fumes or anything that could be harmful to the lungs. So for hearing, we definitely want to conduct a noise survey. So going out and making sure that we know how loud the tools and equipment that we're working around, whether it's engines or compressors or tools that we're using. We want to make sure the exact decibel rating, and that kind of helps determine the level of hearing protection that we need. And then monitoring people through audiograms, typically annually if you are around a lot of loud noises is necessary, and then you want to repeat the monitoring as needed. All right, so hearing protection is also pretty important to determine the right types. You have canal caps, earmuffs, and earplugs. Now, in every case, 85 decibels is kind of your starting point for knowing you need to wear hearing protection. And the decibel ratings, and I've covered this before, are essentially halved because you have 2 ears. So if you buy some hearing protection, it says 15 decibel rating. That's 7.5 per ear. So if you need to be covered at 85, At 92.5, you can get 15. At 30, you can get 100 decibels, and typically that's going to be covered by wearing both earplugs and earmuffs. Canal caps usually only really help at about 2 to 3 decibels over 85. Not a great hearing protection option. So head protection, a few different things about this. You want to make sure it fits properly. You want to make sure it's inspected before each use. You clean it regularly. Use only protect the head, not as a hammer or anything else, or a weapon, as some people have done in the past. And then also, as we've covered in the past, making sure that it's for the right type of hazard, whether it's something falling on you from the top, from the side, or if you're protecting from electrical hazards. So selecting foot protection, we have steel-toed boots. We talked about metatarsal protection a little bit earlier. We have puncture and slip-resistant soles, chemical-resistant boots, waterproof and cold weather footwear, and they all need to follow ANSI Z41. So those are the requirements for foot protection. You also want to make sure that they fit comfortably, inspected before each use, that there's no cracks or holes or chemical holes in them, and then also checking the soles for excessive wear and keeping them as clean as possible. For me, the bottoms of my boots typically get worn out first, so that's something that I need to take care of. Selecting hand protection. Once again, many different types out there. There's chemical resistant gloves, Kevlar, metal mesh, cut resistant gloves typically used in kitchens and where a lot of knives are used, leather work gloves for heat and abrasion, extreme temperature gloves if you're working around really hot or really cold or in those environments, and then also electrical work gloves for arc flash protection. So fall protection is another thing you want to be concerned about, and there's a lot of different types. Typically you want to prevent yourself from falling all the way, even falling to the edge, or rather than falling all the way off, but rather than falling to the edge of something. So you're looking for tightness of fit when you wear this, making sure there's no defects. You need to be able to see the tags. Connectors must move freely, no cinching up or tightening up, and then also making sure your D-ring typically is in the center of your back between your shoulder blades. That's where you want your fall protection to be. Once again, if you can remove the hazard or do the work on the ground, that's the primary option. Hand protection, you want to make sure you have a comfortable fit, it's inspected before each use, keep clean and dry, and then if it's contaminated or damaged, ripped, holes, etc., go ahead and get rid of it. So some other general safety clothing, you have long sleeve shirts. Obviously for us in the oil field, that's pretty much standard. Flame retardant clothing for that reason. Obviously if you have a flash burn, you want to only be burned from your wrists up. You want to make sure that you're completely covered. No loose clothing or jewelry or anything that can be torn off, and then chemical resistant clothing. And the degloving thing is actually a big issue. So you'll see here I've got a picture of a rubber wedding ring, which is what a lot of guys wear nowadays. It just cuts easier. It'll pull off without harming you, and you can still keep your wife happy. So some key points to remember in PPE. Every job function in every department, regardless of what you're doing, should have some sort of hazard assessment. I highly recommend documenting it. And as I said, you can find this information online if you need it. We have assessment forms, pretty straightforward to do. It asks you a series of questions about what's around in your work environment and then helps you determine what PPE is necessary. Each part of the body is taken into consideration during assessments, essentially from the face down. You want to select it in response to each hazard after, once again, you've implemented an engineering control to prevent the hazard from taking place in the first at first. And then properly wearing and taking care of your PPE is necessary to provide effective protection. Electrical safety. Moving on to our next topic for the month. We have a few different objectives for electrical safety. We want to make sure that electrical hazards are protected against, understanding the difference between qualified and non-qualified electrical people, understanding the difference between hazards associated with electricity, and being prepared for an electrical emergency, making sure that you're not in a position where you're going to be harmed. So some terminology before we move on, kind of want to get this covered. Current, we'll mention this a lot, is the movement of electrical charge. Basically, any electrical charge is moving, there's current. Even within the body, we have current. Resistance is any opposition to the flow of current. So there's electrically resistant material and electrically conductive material. Voltage is the measure of electrical force, how much is being put out, and then amperage is the measure of how much is being drawn by whatever, if you have a fuse or if you have a tool, how much it's drawing. Conductors are substances that have little resistance to electricity. Insulators are things that have high resistance to electricity. And then grounding is a conductive connection to the earth that acts as a protective measure by the water in the earth drawing that rogue electrical current and voltage. So there's two worker categories when dealing with electrical safety. The first one is a qualified worker. This is someone who's been trained typically through the NEC code and been qualified to perform electrical work, whether it's wiring things, installing electrical equipment, or repairing electrical components. An unqualified person may have a lot of knowledge, but if they haven't went through the process and been verified of their knowledge, then it's pretty much useless. So in the workplace, rewiring extension cords, doing wiring on the walls, etc. Even if you know how to do it and you've done it at your house and you're fantastic at it, does not matter in the workplace. We need to make sure that you're qualified prior to doing any electrical work. All right, so some quick facts about electrical safety. In 2010, 154 workers were killed by electrocution on the job. And that's a decade old, but still that number, believe it or not, has not come down at all in the last 10 years. If anything, it's increased. So typically construction has the highest numbers of fatalities for electrical safety, and the natural resources is falling behind it. There's four main types. So you have electrocution, which is death due to electrical shots. So if someone says, I've been electrocuted, it's not true. They've probably been shocked, which is essentially just, getting zapped. And then you have burns and falls, which is kind of the follow-up effect of getting shocked, is that if you're on a ladder, you're not harnessed off, then typically you will fall and get harmed that way. So as I mentioned, electrical shock happens when current passes through the body and you get zapped. The severity depends on the path of the current. If it just goes through your arm and out your shoulder, it's just going to hurt your arm. If it goes through your heart for some reason, that's when we have a serious issue. How much current flows through the body, and including voltage and how many amps your body draws, which is determined by whether or not you're touching water or not grounded, and then also how long you're a part of that circuit. So for this reason, low voltage in no way means low hazard. It can be very low voltage, but still, if it's there long enough, cause some serious damage. So anything greater than 2 milliamps can cause ventricular fibrillation. So, thinking when you 15 amp circuit, you're thinking that's pretty small. 5 amp circuit, well, 2 milliamp can cause your heart to change its beat. So that will cause death within a few minutes if without a defibrillator. And a small power drill, as I mentioned, uses 4 to 8 amps. It's like 400 to 800 times more than necessary to cause ventricular defibrillation. So electrical shock is pretty serious. It typically happens when two wires have different potential voltages, and then current's going to flow through them. If you come in contact with one of these, then you will receive a shock. Current will flow through your body. You will receive a shock. And if you come into contact with any of these, with any grounded object, current will flow through your body. You'll essentially become part of the ground, because as the ground draws the current, because it's made of water, you are also made of 70% water, so it will ground to you. Electrical burns happen typically when a shock occurs. Wherever its exit point is typically, and sometimes the entrance point, it will cause a burn. The heat is more than the skin can take, and it will damage the skin tissue. It will damage bone. It will damage muscle. It'll heat up your blood, for goodness sake. So there's a lot of serious stuff that can happen when getting electrically shocked. So it can also cause, as I mentioned before, indirect injuries and follow-on injuries such as falling. So make sure if you are working around electrical at heights that you are and not necessarily even working with, but around. And we'll talk about that here next. So if you're working around electricity, you can experience an arc blast. Typically they say arc flash. It's a similar terminology for the same thing. So it happens when electrical current heats the surrounding air rapidly, causing an explosion. So essentially it uses the oxygen in the air as an element for combustion. Electricity will also travel through that air, coming in contact with a ground source and the heat, and cause a real big issue. So it's something, even if you're not working directly with electrical, if you're working around it and any sort of item comes close enough and the air is heated between those two items, it can cause an arc flash or an arc blast. So overload hazards This system, a GFCI, which typically we see in bathrooms, is what's designed to stop that. So if there's two different types, the one I just showed you is the one in the bathroom. This is another type that they actually installed directly with the circuit breaker, which is kind of the preferred model anymore, so that you don't have to have multiple different types of outlets. And there are different types, different ratings. They can be integrated into the breaker system, and they recognize an interruption. So for example, if you have a handheld appliance that's plugged in the water, and that water starts to draw current from that appliance, the GFCI recognizes, hey, I sent out 120 volts and only 119 volts are coming back. That means something is drawing energy that's not a part of the circuit. It's not flowing back. It's not circuitous, and that's when your GFCI trips, shutting down connectivity and electricity flow. Static electricity essentially is very similar to how a wire works. When you have two different potentials, a positive and a negative, creating a circuit. Well, if you have something that's charged and you yourself or something else comes near that thing, or you get charged up, that potential difference will balance out. And the way that happens, or the way physics create this, is it creates a spark, and essentially that's where the additional electricity goes. And for that reason, we need grounds. And if you're around, especially in LEL or any sort of flammable atmosphere, that's when it becomes serious, because those sparks are very hot. So grounds, essentially, as I mentioned, draw that excess energy, and if there's a ground as a part of the circuit, when the static occurs, it doesn't occur on the surface. It essentially, the ground will draw that static directly out of the air through whatever component it's attached to into the water that's in the ground. And so that's why having conductive material as ground wires is extremely important. Not every type of wire can be a ground wire. It has to be typically copper that's going to draw that current, and is very conductive. So overhead power lines, another issue that we have to worry about. Essentially, for voltages of 50,000 volts or above, you want to keep everything at least 10 feet away. So typically, your overhead power lines are going to be anywhere from 20 to 50,000, and anything over 50,000, you're going to add 4 inches for every additional 10,000 volts. Typically, where we get in trouble with overhead power lines is moving heavy equipment, or rigging, and with cranes, etc. So if you're involved in rigging or moving large items and materials, you always want to make sure that you use some sort of protective measure, whether you use poles with flagging that essentially say, hey, you don't want to get within this distance of the electrical wires, or having a spotter, making sure that everything's within the appropriate distance. So we talked about grounding path already, so we're just going to go ahead and skip past that. However, you definitely do not want to remove your grounding plug if it's designed to have a ground plug, because that means there's a grounding wire within that electrical equipment that is not properly being used, which can cause essentially, once again, that spark to happen at where that plug is. So they have intrinsically safe plugs for this reason, that once again are designed to absorb that excess electricity to absolutely ensure that rogue electrical current goes to the ground. And that's what an assured grounding program is. Assured protective grounding equipment is like, hey, we are absolutely certain, and the cords and wires and grounding paths have been inspected by a qualified person to make sure that they're working properly. And as I mentioned, around explosive atmospheres, this isn't only important, it's absolutely necessary. So if you're working around LELs and you're using hand tools or power tools, and this is really on any location, even equipment that you're working with has electrical current going through it. Vehicles, tools, saws, drills, etc. You want to make sure that they're properly grounded and those systems are working properly as well. So a 3-wire grounding system is essentially the most effective method. As I mentioned, they have different types of plugs for that purpose. It gives electricity a distinct path to take, and the plug is connected to a ground wire. So we talk about this in hand and power tools, but just to kind of reiterate, there are double insulated tools, which essentially came about because back in the day they made tools out of metal because they were heavier, more industrial, and they lasted longer. The problem with that was that if there were any loose connections or wires inside of that tool, then they made contact with the housing of the tool, shocking and sometimes electrocuting. That's going to show you that that's designed to, someone from TTK corrected me. I said that brushless tools are intrinsically safe. That's not actually correct. There are brushless tools that are intrinsically safe, but just because they're brushless does not make them truly intrinsically safe. So you want to make sure you're using the right type of tool for the job. All right, so moving on to cabinets, boxes, and fittings. These essentially need to be covered. The holes need to be covered. The little plates need to be covered. Essentially, anytime you have a box or a junction area, it needs to be covered, and the wires need to be not touching each other as they are in this picture here. You need to make sure that they're wired properly. And once again, this is the reason to have qualified personnel doing your electrical work. Just because somebody's done something at their house. I don't know if you've ever seen Ron Swanson on Parks and Rec, but he wired his whole garage up, and they did an episode where they inspected his garage, and it was absolutely out of control. And people kind of have their own mentality towards what's safe and what's not safe. So making sure that we're absolutely clear on electrical equipment, J-boxes, etc., knockouts, being filled in, and once again being operated and maintained by a qualified electrician. All right, so a little bit more on flexible cords. Obviously, the main purpose of them is to reach objects and appliances that are far away from the outlet. The problem with them is they're not necessarily designed to be in permanent use, especially when in conjunction with outlets or power outlets like power strips. So the problem with them is they heat up over time, they degrade, and we just kind of leave them alone. You don't think about them after you plug them in. So making sure that they're only used in appropriate uses in portable tools, facilitate interchange for stationary equipment, like it's being moved from one place to another, or lighting fixtures suspended from ceilings, like pendants. That's the only time flexible wires can be used. They can't be used as a substitute for fixed wiring. They cannot be run through walls, ceilings, floors, doors, or windows. And, we've all seen it when we've ran it that way and then closed the door on it. It obviously causes damage to the cord, and that's why we don't want to be using it that way. And we don't want to have them be concealed. We want to be able to inspect them consistently. And sometimes in certain environments, you actually have to inspect them monthly and then tag them when you do so. So red flags of electrical hazards, trip circuit breakers that continue to trip. If you have blown fuses, warm tools or wires, you can typically in this case smell them a little bit, that kind of like acrid electrical burning smell. Trip GFCI outlets that continue to trip, and then worn, frayed, scorched, or blackened insulation around a wire connection. All these are signs of concern for electrical work. So electrical lockout tagout is extremely important in these instances, just to make sure that when we're operating or maintaining equipment that it is properly locked out. So there's a lot more covered in our lockout tagout training, but most importantly, you do not want to be working on any sort of live equipment without it being locked out. So PPE for this, we talked about it a little bit earlier. We want to make sure that we're wearing the proper PPE when working around electrical equipment. FRCs designed for electrical arc flash, not for petroleum or LELs. It's actually designed for that. So it has a NFPA rating as well as an NEC rating. Type E hard hats, which most of us have in the oil field. The MSA V-Guard that we wear are typically Type E, which protects against 20,000 volts or your typical overhead power line voltage. Insulated gloves are also important, insulated boots, face shields, and non-conductive hard toe boots. So other equipment that we need to be thinking about is instrumentation panels, especially in PLC environments. Insulated blankets and rubber mats are kind of a necessary for those, just because they're typically housed in metal buildings where the floor and the housing of the entire building are conductive. So making sure you have other protective measures, and they can be put over electrical equipment, once again, to insulate it. You shouldn't really be too worried about heat, although some electrical circuits do require ventilation, so just keep that in mind. Wet area work is also a major issue that we run into, especially in the welding world, on pipelines, etc. When you're out working on the ground, when it's wet and moist, this can once again draw that electrical current. So you want to make sure you're not working in areas where electricity and water are mixing. So if the equipment will get wet, such as during rain or weather events, you want to make sure that it's rated to be in a wet area, and some of them are. Typically, intrinsically safe electrical equipment is rated for wet as well as LEL environments. So never plug in equipment with wet hands, or if the plug is wet, obviously, once again, that's going to cause a spark and a shock, and then you could become part of that current if that water is continuous with your body, because you are, once again, 70% water. So testing for voltage before you mess with anything is important. So even after something's locked out and tagged out, you want to make sure you use a voltage meter to test to ensure the circuit is dead prior to doing any work, or even maintaining equipment if it's not on the electrical system, because it can cause problems and shock. So wrapping this all up this month, I got a couple different items here. Never allow workers to perform work on electrical equipment if they're not qualified to do so, even if they're really good, even if they promise you, even if their name is Ron Swanson. You want to make sure that they're qualified prior to them doing work on electrical equipment. Electricity can be deadly and cause severe injuries such as burns, abrasions, arc flash, etc. Electrical systems can cause fires or explosions as well, and for that reason, you always want to make sure you guard or disconnect electrical systems. All right, well, this month I want to let everyone on our online training know about a kind of an award program that we have. So if you put in a Google or Facebook review for us, or give us a like, we actually enter from January 1st to July 1st, and then from July 1st to December 31st, we have 2 different drawings. I think last year we gave away 2 shotguns, typically as our gift, and essentially we do this to kind of raise awareness about our company and also give back to the people that are a part of our training program. So you just go ahead and search us online. You'll find us on Facebook, you'll find us on Google, and you can just give us a review. And we take all those names, we put them in the hat, and like I said, at the end of every 2 quarters, we do a drawing, and then typically you get a gun, or if you want, a gift certificate. So really appreciate you doing that. As always, at the end of this training, you'll have a little comment box. And people have done this, and it's actually helped make us better. If you have any comments or suggestions or things in the training that you're not quite sure about, go ahead and give us a call or fill out that suggestion box, and we'll get back with you. Thank you very much for being part of the training this month, and we'll see you in August.